Hello everyone and welcome back to Diksha Karnataka YouTube channel. Today is day 23 of the P2 Brahmastra series, where I am going to discuss a very important chapter for your final exam, that is Ray Optics and Optical Instruments. Now if you are wondering what all we are going to do in this week, let's look into the weekly schedule of all the subjects. So Monday was coordination and compound. Today is Ray Optics and Optical Instrument. Tomorrow will be biology, biotechnology, principles and processes, and again Thursday will be solutions. Physics we will be doing wave optics on Friday, and Saturday will be biology as well as mathematics class as usual, application of integrals and microbes in human welfare. Okay, next will be Sunday only maths class is there, application of derivatives. So I hope you have understood what all the chapters you are going to get in this entire week, and let's look into the blueprint for this current chapter. So if you see, all the blueprints are giving about 10 marks, 9 marks and 10 marks in each of the 3 blueprints. So first blueprint says there will be only one MCQ from this chapter, 2 short answer type questions, one will be remembering type, one will be slightly understanding type, and one long answer type numerical question. Again in blueprint 2 there will be one MCQ, one 3-mark understanding question, and one HOTS question, numerical question. Then there will be blueprint 3 says there will be one remembering based question, one remembering based fill in the blanks, one 3 marks numerical question, and one long answer type question, which is a derivation kind of a question. Okay, now from all this previous year experience, this chapter numericals are slightly difficult because lot of varieties, lot of different types of question might come from this chapter. So if you are really interested to solve all the numericals from this chapter, do mention that in the comment below. In future upcoming days I will be trying to solve all the important numericals from this chapter, but right now my focus is to mainly get through all the objective questions, all the 2-3 marks questions, as well as long answer type derivations if they are coming for this chapter. And questions, numerical questions, I have limited to only 2 questions because questions are slightly difficult level from this chapter. So in my opinion, if you are really interested, just don't forget to mention that in the comment below. Based on the response I receive from all of you, I will decide whether to take up this chapter for only numerical questions or not. Okay, so now let's look into the questions from this chapter. What are we are going to discuss? There will be as usual 15 MCQ from this chapter. There will be 5 fill in the blanks, then there will be 3 2 marks question, there will be 2 3 marks question, and 3 5 marks question, very important, and 2 numerical questions as I mentioned. So total 30 questions we are going to discuss from this chapter. So let's start with the MCQ first. An object of infinite height is placed in front of a concave mirror within its focus. It forms a real enlarged image. Object of finite size, not infinite size, my mistake. Object of finite height is placed in front of a concave mirror within its focus. Within its focus means the distance is less than focal length. Now concave mirror, if you remember from your class 10th where you have studied this, if you place an object within the focus, okay, it produces enlarged virtual image, right? So it will be a virtual enlarged image. So option C is the correct answer. Just read the question, understand it, and answer it directly. Okay, you don't need to read all the options, just go through the options. Whatever you know that correct answer is, you just have to pick it. You know that in case of concave mirror the image is virtual, so you have to draw it like this, right? So you get a virtual and enlarged image, virtual image, right? For a mirror, virtual image forms here. It will be virtual and enlarged image. Okay, Next question, identify the statement which is true for a compound microscope from the following. Okay, so first of all you have to identify which statement is true for compound microscope. Its objective is a convex lens of greater aperture. Its eyepiece is a convex lens of smaller aperture. The image formed by its objective is real and inverted. Its eyepiece produces the final image which is virtual and diminished. So compound microscope obviously produces an enlarged image. Okay, and if you see all the options, only option C is the correct answer. The image found by its objective is real and inverted. Now let's move on to the next question. Next question is, a ray of light is incident on a glass air interface at an angle greater than the critical angle for the pair of media. Then the undergoes refraction, only partial reflection. So ray of light is incident on a glass air interface, so it is basically traveling from glass to air. Okay, so denser to rarer medium, and the angle of incidence is greater than that of the critical angle. So answer is very easy. Okay, there will be only total internal reflection. Total internal reflection means there will be no partial reflection, there will be no partial refraction. Entire light will be reflected back. That's why it is called total internal reflection. If the angle is exactly equals to critical angle, then the option D would have been come. Okay, grazes the surface at the interface of the two media, but angle is greater than that of the critical angle, that means total internal reflection. If the angle is less than critical angle, then it will be partial reflection and partial refraction. Okay, so you have to understand that whenever refraction is happening, there will be partial reflection, but in case of angle greater than total critical angle, then it will be always total internal reflection. Now let's look into this question. In case of total internal reflection, light ray must be traveling from rarer medium to denser medium. Light ray must be traveling from denser medium to rarer medium. The angle of incidence must be less than that of critical angle. The angle of refraction is 0 degree when the angle of incidence is equal to the critical angle. So obviously these two options are incorrect in this case. Option B is correct answer. So we know that we are only marking the correct answer, so correct answer is this. Now if you check the other options, so obviously this is very straightforward, that light ray must be traveling from denser to rarer medium. This one is exactly opposite to that of the it, so it should be wrong. And in case of angle, it should be more than that of the critical angle, and angle of refraction is 90 degree when it is exactly at critical angle. So both the options C and D are incorrect. Now let's move on to the next question. A ray of light coming from an object which is incident parallel to the principal axis of a convex lens placed in air after refraction appears to diverge from first principal focus, emerges without any deviation, appears to diverge from the second principal focus, passes through the second principal focus. So obviously it passes through the second principal focus. In case of convex lens, there is no appear to come from unless and until the object is placed close to the focus, less than focal length. Here parallel rays when it falls on a convex lens, they converge, they pass through a point. Okay, when the parallel rays falls on a concave lens, okay, then it appears to come from the first principal focus. Okay, clear? Now this is the correct answer, that passes through the second principal focus. So you have to be careful, it should be always passes through in case of convex lens. For concave lens, it appears to come from. Okay. Now next question, modern telescopes called reflecting telescopes uses a concave mirror rather than a lens for the objective. Okay, so modern telescopes, they use reflecting mirrors rather than lenses. This question is from last year question paper. Now let's see what are the options given. No chromatic aberration in a mirror, giving mechanical support to a mirror is easier. Both options are correct. Okay, chromatic aberration is prevalent in case of lens because of refraction is happening, and we know that different wavelengths bend differently. Okay, So if you are using white light or any colored light mixed with two different colors, then there will be splitting of the colors, that is called chromatic aberration. Okay, that thing does not happen in case of reflection. So basically you can just eliminate the chromatic aberration completely. Secondly, in case of lenses, you can only have the space of the rim to provide the support. In case of mirrors, you have the entire back side to provide the support. That's why all the large telescopes to observe sky are reflecting telescopes. Okay, so both are true. So both 1 and 2 are true. So option C is correct. Okay, this is a very detailed question came from your NCERT. So this question belongs to NCERT. Even though the chromatic aberration and detailed structure of the mirror is not there, but this line was specifically mentioned in your NCERT. So that is why it is important to read the NCERT at least once, so that in case you are confused, you can answer any detailed question, any intricate question that might come from the chapter. Now, Snell's law is invalid for the angle of incidence I equals to. So when is Snell's law invalid? Snell's law is invalid when the ray of light is falling normally. So that means normal incidence means angle of incidence is 0. Okay, it is falling along the normal. We measure the angle with respect to the normal. So basically, when the refraction happens, when the ray of light falling normally, you cannot apply Snell's law because sin I becomes 0. So basically, obviously, you cannot apply Snell's law. So I becomes if I equals to 0, you cannot apply Snell's law. Right? Next question. A light wave of frequency nu and wavelength lambda enters to water from air. So light ray of some wavelength and frequency enters in from air to water. Okay, this is air, this is water. Okay, now let's see what are the options given. Nu will remain constant and lambda changes. Nu changes and lambda will remain constant. Both nu and lambda will change. Both nu and lambda will remain constant. Now, as we know that frequency of any wave is a fundamental property, whereas lambda changes from medium to medium. So obviously nu will remain constant and lambda changes. Okay, based on in fact because they have given that in case of air to water, so that means lambda will decrease in this case, right? Also you can remember that frequency will always remain constant and velocity and lambda will change. Okay, so this is a very interesting question. Now let's move on to the next part. In refraction, light waves are bent on passing from one medium to the second medium, because in the second medium the frequency is different. So again a similar question, frequency obviously not different, frequency is same. The speed is different, the coefficient of elasticity is different, the amplitude is smaller. So amplitude does not matter, only thing is speed is different, that's why it bends. Okay, other options are incorrect. Okay, frequency is same, coefficient of elasticity does not matter, and amplitude of the wave does not matter. Only thing that matters is speed, because different speed if the medium is rarer, if the light is traveling from denser to rarer medium, okay, then light ray will bend away from the normal, and if the ray is traveling from rarer to denser medium, after refraction the light ray will bend towards the normal. Okay. Now, next question, the relation between focal length and the radius of curvature of a mirror is. So, relations between radius of curvature and focal length, we know that focal length is equals to radius of curvature divided by 2. Okay, so correct answer is option C. Right? Now, let's move on to the next question. Optical fibers are used in telecommunication, transmit data, endoscopes, all of the above. It is used in all of the above cases. It is used in telecommunications. Okay, for example, the telephone line, landline, if you are using landline, so they depend on optical fiber. Then even if you are using mobile tower, if you are thinking that okay, I am using mobile phone, so no optical fiber is used, you are wrong, because when you are doing a long distance call, first the mobile phone connects to the local tower. From that local tower the data is getting transmitted through optical fiber, and from that optical fiber it is reaching to the receiver's nearest tower. From there you are your data is again transmitted via wirelessly to the receiver mobile, right? So even if you are calling from mobile, it is also using optical fiber. Transmit data, we know that in all the fiber network, if you are using fiber network at your home, okay, they are using optical fibers. Endoscope is a device to test if something is problematic inside your body, human body. So they put some camera in using optical fiber into your body, and they test if there are some ulcers or some cancer or some tumor, etc. is there. So endoscopes also uses optical fiber. Next question, the total internal reflection is possible when light is traveling from air to water, water to air, air to glass, all of the above. So obviously light ray should travel from denser to rarer medium, and in this given option only water to air is the possible answer. So water to air, when the light is traveling from water to air, total internal reflection is possible, right? In case of air to water or air to glass, light is traveling from rarer to denser, so definitely it is not possible. Now next question, velocity of light in air is 3 times 10 to the power of 8 meter per second, and velocity of light in medium is 1.5 times 10 to the power of 8 meter per second. What is the refractive index of this medium? So refractive index is speed of light in vacuum divided by speed of light in that medium. Okay, so 10 to the power 8 cancels, so refractive index is 2. Simple formula. Okay, only one line formula you have to remember to answer this question. Next question, the lens nearest to the object in a microscope is called object lens, objective lens, the eye lens, the eyepiece. Okay, so the lens which is nearest to the object is called objective lens, okay, or only objective, okay, either objective or objective lens. So this is the lens which is nearest to the object, not object lens. You have to be careful. One problem with a reflecting telescope is that the objective mirror focuses light. So this is one of the problems of reflecting telescopes. Okay, what could be the possible problem? After reflection, because this is, suppose this is the objective lens, this objective lens is always a concave mirror, right? Now after the rays are falling on the mirror, okay, they always meet here. Okay, so the rays try to focus inside the tube. Okay, so rays always focuses inside the tube, but how can you see that rays are getting focused inside the tube? So how to do that? There is a Cassegrainian telescope. They use a convex mirror here. Okay, after concave mirror, they use a convex mirror. Okay, after reflection, there is a convex mirror, and here they keep some hole. Okay, here they keep some hole. Okay, so that after getting reflected from here, the rays can meet here and you can see the object here. Okay, so the main problem of a reflecting telescope is that after reflection, the rays objective mirror focuses light inside the tube. Okay, so inside the telescope tube, that is the problem of a reflecting telescope, but that can be overcome using mechanism that is shown here. There are different types of mechanism. Okay, in some cases they put the optically sensitive element here at the focal point. Okay, or they keep some element, some sensor which can sense the light. Okay, there are different types of ways to collect the data. Okay, this is one of the oldest technology used by Cassegrainian, so that's why it is used in Cassegrainian telescope. Okay, if you are interested in astronomy, you can go and search about Cassegrainian telescope in Google and read more about it. Okay, now let's look into the fill in the blanks question. A microscope is used to produce large dash of small objects. So a microscope is basically used to create images, right? So when you are looking into the microscope in your bio lab or in your physics lab, so basically it is producing large image of the small object. If the object is small, you are actually not seeing the object, but you are seeing the image of the object. So it is large image. Okay, image is the answer. Okay, next is optical fibers are based on the principle of total internal reflection. Okay, so optical fibers are basically based on total internal reflection. So I am writing TIR in short. Okay, if you are not able to understand, I am writing 17 here as well. Okay, so here is 16. Next question, the reciprocal of focal length is dash. So reciprocal of focal length is called power. Okay, provided the focal length is measured in meter. In SI unit obviously they are measured in meter, so reciprocal of focal length is power. Dash mirrors are used as rear view mirrors of car. So what type of mirrors are used? Convex mirrors are used. Okay, convex mirrors are used in case of rear view mirror of cars. The image formed by a simple microscope, this is not image, sorry, this will be image. The image formed by a simple microscope is so only power is also done, right? So only option that is left is virtual or real. So the question is, image formed by a simple microscope is virtual or real. A simple microscope is basically a simple convex lens. Okay, so if you have seen very common picture of Sherlock Holmes or any other detectives, they use the microscope, they use the convex lens, and it appears something bigger, so they search for clues using that lens. That was typical in the olden days. Now that is basically a virtual image. You have to be careful. Image formed by a simple microscope is a virtual image because it is magnified, right? So convex lens only produce magnified image when it is producing virtual image. Okay, if it is producing any other image, then obviously it is real image. Real image you have to see it in a screen. Convex lens can produce magnified real images, but for that you have to use a screen. But if you are using it to detect small objects, then basically you are using it for virtual image. Okay, you have to be careful. Okay, now next question, name the objective. So this is also again based on microscope. Name the objective used in refract. Objective means objective lens. Okay, here even though they have mentioned objective, because objective lens sometimes only referred as objective. So if they give you the question, name the objective, oh, what is the objective? What is the objective? Objective means many can refer to many other meanings in English, but in this case objective means the objective lens. Okay, be careful. So the name the objective used in refracting type telescope and reflecting type telescope. So what is the objective used in refracting type telescope? Convex lens is used as refracting in case of refracting telescope, and in case of reflecting telescope, as I mentioned earlier, concave mirror is used as objective. Objective means which sees the object from the first device from where the light from object falls on that object. Okay, so the lens or a mirror which is facing the object from where the light is falling on it, that is called the objective. So in case of refracting telescope, convex lens is the object lens. Okay, and in case of refracting telescope, concave mirror is the objective mirror. Okay, so basically they have tried to simplify it. Instead of objective lens or objective mirror, they have just mentioned objective because it relates to lens as well as mirror. Both are being referred to here using this term objective. Okay, now write the two conditions required for total internal reflection. This is a very common question, mostly asked question. So let's look into the answer. Light must travel from denser to the rarer medium. Okay, very important, denser to rarer medium, and the angle of incidence must be more than that of the critical angle. Okay, right? Now how does the power of a lens varies with the focal length? So power of a lens basically is inverse of the focal length when f is in meters, right? Thus power is inversely proportional to the focal length, right? 2-mark question. So you have to write the formula and you have to mention that power is inversely proportional to the focal length. So you just write 2 lines, you will get the full answer, full marks, okay? And also you have to mention where when f is in meters, okay? F is expressed in meters or f is in meters, okay? Now let's look into the next question, 3-mark question. It is a numerical question. A small candle is placed at a distance of 20 centimeter in front of a concave mirror of radius of curvature 30 centimeter. So a small candle is placed in front of a concave mirror, okay, distance of 20 centimeters. So u is 20 centimeter. Concave mirror of radius of curvature is given 30 centimeter, okay. At what distance from the mirror should a screen be placed in order to obtain a sharp image? What is the nature of the image? So nature of the image, obviously this is clear, they are asking you to place a screen. So screen means obviously the image will be a real image, right? Now let's see the formula. 1 by v plus 1 by u equals to 2 by r. This is the mirror formula, okay. Be careful, in mirror formula everything is positive. And now we have to put the signs. Very important is the sign convention. What is the sign convention here? U is always negative, u is always negative, okay. And r for a concave mirror is negative, r for a concave mirror is negative, okay. So let's do that. Minus 15, so it is 1 by minus 15. Now let's take this on the other side and calculate v. So 1 by v. If you have any problem regarding the sign convention, you can check my cassette video. There I have discussed about the sign convention, okay. Sign convention I have not seen in previous year questions, recent previous year questions. The question is not super important. It used to come, it may still come in your preparatory exam, but that question is not super important for your board exam, okay. But don't blame me if that question comes in your board exam, because in after 7-8 years back, that was a popular question. Right now there are a lot of other good questions, so that's why this is not coming very frequently. So what is the LCM for this? LCM for this is 60, okay. 20 3 20 is a 60 minus 4 15 is a 60, so it will be minus 1 by 60. So v equals to minus 60. So where you have to place the screen, you have to place the screen at a distance 60 centimeter from the mirror, and the nature is basically real image, okay. From two things you can say it's a real image. First of all, they have asked you to place a screen, so obviously if you are placing a screen, that is a real image. Secondly, the v is negative. The negative v means it is on the left hand side of the mirror. Now mirror reflects the light, so mirror reflects the light, and if the image is forming on the behind the mirror, then only it is a virtual image. So because it is forming in front of the mirror, so that means it's a real image, okay. So nature of the image is real image. You have to mention that, okay. Now let's look into this question. Derive the relationship between radius of curvature and focal length in case of a concave mirror. This is a very common question, okay. How to solve it? So first of all, you have to consider a concave mirror. The ray diagram is very important in this case. Okay, suppose this is the center of curvature, this is the focal length. So they have asked you to find the relationship between radius of curvature and focal length. Okay, so sorry, one mistake I made in this diagram is this should be capital F, not small f, because small f is the focal length. So this is small f, this distance is small f, and this distance is capital R, radius of curvature and focal length. So we have to find the relationship between them. So what you have to do, first you have to consider a parallel ray. I have seen the students, they are drawing the diagram and they are not properly explaining the diagram. So that is very critical. Okay, so and this ray after the parallel ray is falling on the mirror, okay, they will pass through the focus. That is the definition of the focus, right? Parallel ray after falling on the mirror, they will pass through the focus, right? Now you have to join this center of curvature and this. Okay, now by definition this is the angle of incidence, say theta. Then from the law of reflection, this will also be angle of reflection, so this will also be theta, right? Now if you consider this line, you can see here you are seeing a Z. So Z means this is an alternate angle, so this angle will also be theta, right? If this angle is theta, this angle is theta, this angle will also be theta. Why? Because first of all, this is from the law of reflection and this is from the geometry by alternate angle. Alternate angles, they are equal, so that's why this is equal. Now if you apply the law of triangle, in case of triangle, we know that this is very important law for triangle. If this angle is say x, this angle is y, and this angle is z, then there is a property of triangle, z equals to x plus y. Okay, any external angle is equal to the sum of the opposite internal angles, right? So this is the external angles and these are the opposite internal angles. So opposite angle equals to the sum of the two internal angles, right? So this is the property that you have to remember, and not only here, in our future derivations as well in this chapter we will use this formula. Okay, this property, not formula, this property. Now this is a triangle, right? This is a triangle, this is an external angle. If you see, we have extended this side, so you can say that this is a side, we have extended it, right? So this angle is basically sum of the two angles, right? So this is basically theta plus theta, that is 2 theta. If you understand that, if you remember this, then there is no chance of any mistakes. I have seen students, they start with some random angle, they make angles randomly and they forget what angle was what, because they don't try to understand it, they try to memorize it, which is a very bad habit. If you are doing any derivations, do not try to memorize everything. Try to apply your brain as much as possible in case of difficult times, and especially if you are like someone who is not very good at remembering everything. Okay, if you have a photographic memory, if you can remember everything, then good, remember whatever you can. But if you are not having a photographic memory, if you cannot remember everything, then what you can do, you can analyze it during the exam, and this is a small analysis, you can do that, and if you remember the analysis, it takes hardly 5 minutes, right? Now this is a 3 marks question, so it should take more than 2 marks question, right? So you can spend that much time here. Now this angle is theta, this angle is theta, this angle is theta, this is 2 theta. Now let's draw a perpendicular and name this, say, MN. Okay, let's name this MN. Okay, now let's see all the triangles here. What are all the triangles at play here? From this triangle MCN, from the triangle MCN, okay, we can say that, and this is the optical center O. Now from this triangle we can say that tan theta equals to perpendicular by base. So MN by CN. Now here we will apply two things. Okay, what two things? First of all, we will apply that this is a paraxial ray. What is the meaning of paraxial ray? Paraxial ray means this point M is very close to the optical center. Right now we cannot draw this diagram as if it's a paraxial ray. For example, if I draw this diagram like this, will you be able to see this correctly? Will you be able to understand it? It is a waste of time. It will be like you need a microscope to see this thing, right? So basically when drawing, we will draw it as if the ray is very far apart, but while understanding it, we will assume in our head this is a paraxial ray. So now what will happen if it is a paraxial ray? If the ray is paraxial, then the angle of incidence, the value of angle of incidence will be very, very small. So basically in that case we can say that if the angle of incidence is small, then tan theta is equals to theta. So for tan theta equals to theta. And one more thing that we can say, if the ray is paraxial, then this point M is very close to the optical center O. So basically this N is exactly at O. So instead of writing Cn, we will write Co. Okay, so this N point and O point, they will almost merge, they will be so close that this perpendicular that you have drawn from point M to the principal axis, that point will exactly match with that of the optical center. So this is the two approximations that we have done. So for paraxial ray, first of all, tan theta is equals to theta, and Mn by Co, Mn by Cn becomes Mn by Co. Now from again we will take another triangle. First of all, you have to understand which two triangle to take. So we will take this triangle. Okay, why this triangle? Because this includes this length. This length is R, right? So you can say this is basically Mn by R. Okay, because CO is the R, right? So that is why we have written this. Similarly, for triangle MFN, again triangle MFN, you have to understand which two triangle to take. First you have to take the bigger triangle, next you have to take the smaller triangle. These two triangles only you have to consider, nothing else. From the triangle MFN, tan 2 theta. Tan 2 theta means this is the 2 theta angle. Tan 2 theta means perpendicular by base. Perpendicular is again Mn, and base is Cn, not Cn, sorry, Fn. Right, now again we will apply this same concept for paraxial ray. Tan theta will become theta, here tan 2 theta will become 2 theta equals to Mn divided by Fn will become Fo. Why Fo? Fo is basically the focal length, right? So that is our objective. In our hidden mind, we have to remember what is our objective, what is our agenda, right? We want to establish some relationship between R and F. So we will only consider the triangles which involve R, which involves F. Do not ever consider this small triangle. This is not required. This triangle is not at all required. Now if you put the value of theta from here in this equation, you can write 2 times theta was Mn by R. So Mn by R. In this side we have Mn by F. Now Mn is common and it is not 0, so Mn will cancel. So 2 by R equals to 1 by F, or F equals to R by 2. So this is the derivation. If you derive this, you will get full 3 marks, small derivations, and it is often asked from this chapter. Now let's look into the next question. This is a 5 mark. From now on, it is a 5 mark derivation. Derive the expression for refractive index of the material of the prism in terms of angle of minimum deviation and angle of the prism. So first of all, you have to draw this diagram very carefully. This derivation is slightly tricky, so that's why I am giving you entire suggestion, all the things that you have to do. First, you have to draw this entire prism diagram, okay, with the scales and pencils, and you have to draw this diagram as well. Now you have to write minimum angle of deviation is given by delta m is equal to 2i minus a, that is I equals to a plus delta m by 2, and there you have to mention a is angle of prism is given by 2r, so the refractive index of the prism is given by n 21 is equal to sin I by sin r, and from there you can do that. But before writing that, you have to mention that delta is equals to I1 plus I2 minus A. Now from this diagram, and A is equals to R1 plus R2. Okay, these two equations you have to start with. We know that. We know from geometry. This part you don't have to prove. This part you can take. Now after you write this part, from the graph we see that for minimum deviation, for angle of minimum deviation, I1 equals to I2 equals to I bracket say, and R1 equals to R2 equals to R again say. Basically you are assuming. Okay, so for angle of minimum deviation happens only when I1 is equals to I2. Okay, from there onwards you can write this. Okay, so this is the derivation that you have to do for this question. I have seen many students start with deriving this formula. This formula derivation is not required. Many students, they only write down the final formula without any explanation. Okay, that is also not correct, and even if someone draws the first diagram, they don't draw the second diagram. This is very, very important, the I versus delta graph. Okay, and as you can see, delta becomes smallest at only one point of I. So basically for any other point you can see there are basically two values, right, I1 and I2, but only at this particular value I1 becomes equals to I2. Okay, in your book they have used I and E, you can mention I1 and I2. Okay, I like to write I1 and I2, so whatever formula or whatever symbol you are familiar with, you can use that. Now next question, this is a long derivation. Deduce the relation between N, U, V and R for refraction of spherical surface where the symbols have their usual symbol. So first you have to draw, in this case only one diagram is needed, that is this diagram. Okay, now in this diagram what we will do, we will mark three more angles. This angle say alpha, okay, we will say this angle is beta, this angle we will say gamma. Okay, if you are confused with R, then you can use any other symbol. Let me use another symbol, delta. Okay, because this gamma symbol is very same with this reflection, angle of reflection R, so I will use another angle symbol delta. So these three angles you have to mention. That will save your time, that will make your life much easier. Okay, in your book they have done all the things as angle MNN, angle MNN, angle OMN, like that. So we will not do that. We will just simply mention at the beginning of our writing, that we will mention angle MON equals to alpha, angle MCN equals to beta, and angle MIN equals to delta. Okay, so this will save our lot of time. So first what we will do, again any derivations for optics, okay, especially when you are doing the derivation without using any formula, is based on the principle of concept of triangles. Okay, angle of incidence equals to angle of reflection, and triangles, they are very highly used in case of refraction and in case of reflection as well. As you will see, also one more fundamental approximation that we will do, we assume that the rays are paraxial. Paraxial rays means the ray is not bending like this, they are very close to the principal axis, and the angle is very small. This point and this point are actually same. So M, in fact in this case they have only shown M, and they are assuming this is basically M. Okay, so they have also reduced the task for you. So we will use the same thing to proceed. First we will use the triangle NOM. Okay, from triangle MOM. What is this? First of all, let me explain the diagram first. This is the object, okay, this is the image. O stands for object, M stands for image, M stands for the medium through which it is refracting, N is a ray of light, ON is the incident light, and NI is the refracted ray. Okay, so these are the main two things. This is the center of curvature for this surface. Center of curvature is R. Now this is not a mirror, so light ray is obviously not reflecting, they are basically refracting in this case. Now let's use this triangle ONM or OMN. OMN. So first we will use each triangle having an angle marked, we will consider one triangle one after another. First we will start with alpha, then we will use beta, then we will use triangle gamma. Okay, and also every time we consider one triangle, we have to consider one triangle which has a right angle, so that we can write down the formulas for tan theta easily. That is one of our shortcut. So what is this triangle? OMN. So in this case the angle is written alpha, so you have to remember these three angles are important, so that will help your life. So tan alpha equals to, what is the tan alpha? This is the angle, so this is the perpendicular, this is the base, right? So this is the perpendicular, perpendicular means MN, and base is OM. Okay, or you can write MN divided by object distance U. So as you can see, this is the object distance, so this is the object distance U. Now for paraxial ray, alpha equals to MN by U. Okay, now again we will use the triangle. Next triangle is, first alpha triangle is done, next is beta triangle, right? We will use the beta triangle. What is the beta triangle? Beta triangle is CMN. In this case tan beta. First of all we will find all the angles, then we will see how we can relate them. Okay, tan beta is basically perpendicular by base. So this is the triangle beta, this is the angle beta, so opposite to that is the perpendicular, this is the base, perpendicular is MN again, and base is, if you see, this is the radius of curvature, so instead of writing CM, I will write directly R. Similarly, beta can be written as MN by R, right? Again, from triangle IMN. Now IMN, can you tell me the angle value delta directly without using the thing of requiring to write the tan delta. Okay, so delta is basically equals to, so if you see, everything starts with mn by this, for this mn by this, so for delta it will be mn divided by this entire thing, right? That means v. So mn, everyone has mn as common, and it will be divided by v in this case, right? Now again we will consider this image, and we will find what is the relationship between the angles alpha, beta and delta. What is the relationship between these three angles? Okay, first we will see that this is the angle of incidence I. Okay, this is the angle of incidence I, this is the angle of refraction R. Now how this angle I is related to alpha and beta? So if you see, this is a triangle. This is a triangle, right? This is a triangle means, if you consider this triangle, then from there this is an external angle, these two are internal angles. So if these two are internal angles, then basically you can say that we know that the sum of two internal angles equals to external angles, so I equals to alpha plus beta. Okay, so from this triangle, this is the triangle, okay, and this is the external angle. So from here you can say that this angle should be sum of the internal angles. Okay, this part is easy. Now you have to find the relationship between R, delta and beta. Okay, how can you do that? R, delta and beta. Now if you see, R plus delta, these are the internal angles, right? So R and delta are internal angles, whereas beta is the external angle in this case. So triangle is like this. Okay, this is R, this is delta, this is beta. So now in this case, if you add these two angles, you should get beta. So R plus delta equals to beta, or R equals to beta minus delta. Okay, so these are the relationship that we have calculated. Now what else? What we have to do? We have to use the Snell's law. Snell's law states that N1, this is N1, okay, sine I1 equals to N2, sorry, in this case we don't need I1, we just write N1 sine I equals to N2 sine R. Now in case of paraxial ray, what else we can say about it? In case of paraxial ray, we can also approximate that sine I equals to I, that is sine theta equals to theta. So in this case we can approximate that for paraxial ray. Here you have to mention Snell's law. Okay. Now for paraxial ray, we can say that N1 I equals to N2 R, right? So this part is done. Now we have to put these values and then simplify. So N1 times I, what is I? I is alpha plus beta. Okay, equals to N2 R. What is R? R is beta minus delta. Okay, now put the values. Put the values. What was the value of alpha? Value of alpha was mn by u, right? Value of alpha was mn by u, beta was mn by r, and delta was mn by v. So everyone has mn in the numerator, only denominator changes. For alpha u, so for alpha it is mn by u. For beta it is mn by r. same here, mn by r, and for delta it is mn by v. So in this derivation there should be one thing that I have made a mistake, that u is always negative, so you have to put a negative u here. Okay, so negative u you have to put here, so that you have to be careful about. Other distances v and r both on along the positive x-axis, so r and v will be positive but u will be negative. Now let's look into the derivation again. Here you will have a negative u. Now let's cancel, mn will be cancelled from each of the terms, right? So mn will be cancelled, so you will be left with the formula will be much easier now. N1 by minus u plus N1 by r equals to N2 by r minus N2 by v. Okay, mn cancels. Now take this minus v on the this left hand side, so it will become positive, so we will get N2 by v minus N1 by u equals to, this will go on the right hand side, N2 by r minus N1 by r. Okay, so this is the formula, this is the relationship between n, v and u. Let me rephrase it a little bit. N2 by v minus N1 by u equals to N2 minus N1 by 1 by r. This is a simpler formula. Also, in case first medium is air, in case N1 belongs to air, then N1 becomes 1 and N2 say equals to normally n, then we can write n by v minus N1 by u equals to N2 minus N1 by 1 by r. So for first medium is air, second medium is normal medium. This is a modified formula, but most commonly the formula that we use is this one. Okay, and this is a modified formula, but you can leave your answer here, you will get full marks for your calculations. Okay, now let's move on to the next question. Here we will do the derivation of Lensmaker's formula. In this case we will use whatever the formula that we have derived in the previous case along with the sign. Okay, first we will use the first surface. In this case, suppose this is a spherical surface. You can consider this is a spherical surface of radius of curvature, say r1, and this is a second spherical surface of radius of curvature r2. Right now, as you can see, r1 is positive and r2 is negative. Why? Because r2 is for this surface, right? So this surface is on the radius of curvature should be on the left hand side. So basically r2 will be negative, u is negative as usual, v will be positive as usual, right, in this case, particular case. Now for the surface 1, so this is surface n1. For surface n1, what we can say is that this medium is air, right? So n and this medium is glass of refractive index, say n. Okay, so n2 by v, and one more thing that you have to remember, that the first surface will form an intermediate image. Okay, so basically you can say that this is the first surface, the ray of light is traveling from here to here, there will be a intermediate image at a distance, say v dash. Okay, now for the second surface, this will act as an object. For the second surface, this will act as an object and it will form a image some distance, say v. This is the final v. So this v dash is the intermediate object that we will use for the first case. Okay, so what is the image distance in this case? Image distance will be V dash, and this is inside this glass surface, so that's why the refractive index of glass we are using, minus air is 1 by u, right? N by V dash minus 1 by u equals to N minus 1 times 1 by R1, right? So this is the first surface formula. What is the next surface? For the second surface, now the object is inside the lens, so instead here it will be minus N by V dash, and the final image is outside in air, so air's refractive index divided by the final image distance, right? 1 by V minus 1 by U, so that is how we write. So now this will be equals to 1 minus N times 1 by R2. Why 1 minus N? Because now light is traveling from denser to rarer medium, so it will be 1 minus N, or you can write this as N minus 1 minus 1 by R1, so the negative sign is accommodated for, so either you can write N minus 1 minus 1 by R1, or you can write N minus 1 by 1 by R1. Okay, now just add them. So if you add them, this and this will cancel, so you will get 1 by V minus 1 by U equals to N minus 1 by R1 minus 1 by R2. So this is the formula for lens maker formula. One more thing, if object is at infinity, then image is formed at focal length, right? If object is kept at infinity, we know that if the object is kept at infinity, image is formed at the focus, right? So if you put that 1 by infinity is 0, so 1 by focal length equals to N minus 1 by R1 minus 1 by R2. Now this is just the derivation part I have explained. You have to slightly describe this image, and you have to explain that for normal surface refraction, we know the relationship in case of a spherical surface is given by this formula, okay, and intermediate object distance is V dash, then you can write this equation. Okay, so whatever the image is formed by this surface, that is V dash, that image will act as an object for the second surface. Okay, this surface is not seeing this original object. This surface is seeing whatever image is being produced by this first surface, right? That is why we will use V dash for this subject, and this is the image for the first surface, and V dash will become object for the second surface. Okay, clear? If you have any doubt, don't forget to mention that in the comment below. Now let's solve two numericals. First numerical: an equilateral prism is made of glass of unknown refractive index. A parallel beam of light is incident on the face of the prism. The angle of minimum deviation is 40 degrees. Find the refractive index of the material of the prism. If the prism is placed in water of refractive index 1.33, find the new angle of minimum deviation of parallel beam of light. So first they have given you the equivalent equilateral prism made of glass of unknown refractive. Equilateral prism means the prism of equilateral prism basically means the angle of the prism is equals to 60 degree. Right, equilateral prism means angle of the prism is 60 degrees. Now we know that refractive index in case of a prism is given by mu is equal to sine A plus delta minimum by 2 divided by not mu, let me write refractive index So when I was a student, we used to represent refractive index using mu. Nowadays all the books they use refractive index using n. So sometimes I use the old forms that I have learned. It changes from year to year based on, because mu is used as a constant for different values, so that's why mu is no longer used as a symbol for refractive index. For example, we used to use the symbol f for frequency. Now nu is more preferred for frequency, right? So now sine A plus delta, A is 60 degrees, okay, minimum deviation is given 40 degrees, okay, by 2, sine 60 by 2, okay, so it will be 100 degrees by 2, so sine 50 degrees divided by sine 30 degrees. Now sine 50 degree has no direct value, okay, you can assume it is close to 45 degrees for now, okay, and you can use the value as 1 by root. I am using 1 by root 2, which is not 100% correct, okay, and sine 30 is half, so it will be 2 divided by root 2, so it will be root 2, so approximately 1.4. Okay, is the approximate value, and in your calculator, if you can calculate the value of sine 50, you can put that exact value and calculate the exact value, but this will be the closest answer for this. Okay, this question is taken from your sample question paper. Obviously the data is okay but not super okay, okay, they are not good. Data is just okay, not good, because if their data was good, then they do have given you the angle of minimum deviation maybe 30 degrees, so that after adding with 60 degree you would get exact 45 degrees, right? But they have given you some data which can be divisible by 2, but it is not super good because it is not calculated. You cannot calculate it exactly using a table, not even 53 degrees. If it was 53 degrees, there was a value available for sine, right, 3 by 5. So that is also not correct, right? And now let's see what will be the answer. 4 by 5 for sine 53 degree, cos 53 degrees 3 by 5. Right, so that is also okay, but that value is also not given, so you cannot check what is the exact value, but you can do it like this. Now let's see the second part. Let's use the second part. Second part, it says that now it is immersed in water having refractive index 1.33. Now what is the new refractive index? The refractive index of the glass with respect to water is given by refractive index of the glass divided by the refractive index of the water. Okay, and that value, this is also not a very good value, okay, it will be somewhere around 1 point something. You can calculate it using a calculator. I don't have a calculator, so I am not using it. The data is not perfect, okay, 1.1 perhaps. This will be equals to, and in this case sine A plus delta m dash, new delta, by 2 divided by sine 30 degrees. Why 30 degrees? Because this A by 2 is not changing, right? So A by 2 is 30 degrees, so it will remain 30 degree, right? So sine A plus delta m by 2 equals to 1.1, sine 30 is 1 by root 2. So it will be 1 by root 2. Assuming they are very close to each other, what we can say that this is exactly equals to 1 by root 2. This is again an approximation. So A plus delta m by 2 will be equals to you can calculate it is not correct. You can calculate the value and you can get the value to be 1.53 and 10 degrees. Okay, you can put the exact values and using calculators you can calculate. I have calculated 1.5414, but if you put exact value of sin 50, then you will get the answer as 1.53 and the angle will be very close to 10 degrees. Okay, which is not super good in my opinion. Next move on to the last problem. An object is placed at a distance of 0.3 meter from a convex lens of focal length 0.2 meter. Find the position and the nature of the image formed. Also find the distance through which the object would be moved to get an image of the linear magnification -1. Okay, so the focal length is 0.2 meter and object distance is 0.3 meter. So basically 20 centimeter and 30 centimeter, but they have given in terms of meter, so we will use the meter only. Okay, we know that the formula is 1 by v minus 1 by u equals to 1 by f. Now here, because the lens is given directly, you have to use the sign convention. What sign convention? We know that in case of convex lens, object distance is always negative, so it will be minus 0.3, and for convex lens the focal length is also negative. For convex lens, focal length is positive. Concave lens, it is negative. So focal length is 0.2. Okay, so 1 by v plus 1 by 0.3 equals to 1 by 0.2, or 1 by v equals to 1 by 0.2 minus 1 by 0.3, that is equals to 3 to okay, let me do one thing. What I can do, instead of writing 0.2, 0.3, I will write it 10 by 2 and 10 by 3. I guess that will be easier. Okay, or it will be, so if you do the LCM, 3 to the 6, 660 minus 20, that is 40 by 6. Okay, so this is 1 by v. Now remember that this is actually in 1 by v, so v will be 6 by 40. Okay, 6 by 40, so it will be 3 to the 6 and 20, or 1.5 divided by 10. How did I do? 3 divided by 2 is 1.5. So 1.5 divided by 10, or it will be 0.1. If you are using calculators, this is very easy to calculate. You can even directly apply calculator here and calculate it. But I like to solve because I teach in competitive classes, so where the calculators is not allowed, so I try to solve all the problems without using calculator. Sometimes I get the correct answer, sometimes I don't. Right? For example, in the previous problem, the answer is not exactly matching, but if it is in a competitive exam, I can guess the answer from based on my calculations. Right? So that is a way. Now, as you see, the object will be forming, the image will be forming at a distance 0.5 meters. Okay, so the position and the nature, as you can see, the image distance is positive. Image distance is positive for a lens. That means it is a real image. So nature is real image, and real and inverted, obviously inverted. Real means obviously it will be inverted. Okay, how can we say inverted, sir? You can calculate the magnification. Magnification is v by u. V is 0.15 and u is minus 0.2. So it will be somewhere 0.75, minus 75. okay, minus 0.75, that will be the answer. Because this is negative, the magnification is negative, that means it is inverted, okay, and it is diminished. So real, inverted, diminished, everything you can calculate if you calculate the magnification. Now the second part, even though these are not asked, you can show that if you are interested, but the main part that is asked is that also find the distance through which the object should be moved to get an image of the linear magnification -1. Now in case of a convex lens, okay, linear magnification is obtained when the object is placed at a distance of distance equals to 2f. Right, we know that if the object distance is 2f, we get a real image, real and inverted image of the same size. Right, so if the object size is same as that of the image size, in that case only we get a real image. This is just an analytical solution. You don't need to do any mathematics to solve the second part. Second part you can solve using analytics. What is analytics? Analytics means we know some cases and we will utilize that to solve this part. Okay, so first we know that u is equal to 2f. When the object distance becomes twice that of the object distance, the linear magnification becomes -1. -1 means exactly what is the meaning of -1 first. -1 means the size of the image is exactly same as that of the object, right, but it is inverted, that's why minus. So from this given data that the focal length is 0.2 meter. So focal length, I made a mistake here. Focal length is 2 meter, 0.2 meter, that means object distance will be 0.2 times 2, that is 0.4 meters. Okay, this should be the object distance. Now how much distance the object should be moved? Initial was 0.3 meter, so the object should be moved by a distance at delta x equals to this is the new u dash minus u, that is 0.4 minus 0.3, that is 0.1 meter. Okay, so object should be moved by a distance of 0.1 meter. Let's check the answer. So 0.6 meter, real 0.1 meter. Okay, so this is the answer. How you can solve such questions. I will be back with a new chapter, and I hope you enjoyed this session. And tomorrow there will be biology class. I will be back on a Friday with a new chapter. Till then, bye.